Welcome to today's webinar, Intent-Based Networking with Big Cloud Fabric. My name is Angelique Medina. I'm the Senior Product Marketing Manager at Big Switch Networks, and I'll be your host for today's webinar. Joining me is Prashant Gandh, Big Switch's Chief Product Officer, and later on during our Q&A session at the end, we'll be joined by Director of Product Management, JP Shukla. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or if you have questions on an upcoming webinar topic that you'd like our panelists to address, email us at info@bigswitch.com. We've also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. We have a pretty full agenda for today's webinar, so we're going to go ahead and get started. So joining us again, Prashant, welcome.
Perfect. Thank you, Angelique. Pleasure to be here. It's a very important topic as we see that the wind of change are blowing in the IT industry. We're all experiencing it. We're all seeing it. And these winds have been created by hyperscalers, Google, Microsoft, Facebook, who have already disrupted networking by deploying open networking switches and writing their own software to drive these switches or operate these switches so that they get tremendous agility, speed, they get tremendous operational simplicity, and they're able to troubleshoot rapidly. And this is the reason why they have been able to deploy such large infrastructure with very, very efficient teams. And so how do we bring these disruptive capabilities to transform data center networking in enterprise and service provider environments? And that'll be the topic of today. And the key theme that we will be focused on is ability to leverage intent as a way to operate the infrastructure. And we'll see that that really changes the way we think about networking and the way we have operated networking for the past 25 years. And much of that operational practices has not been changed. So the agenda today would be, we'll kind of look at the data center trends, and then what is intent-based networking. We'll also look at the industry perspective and how that maps to real-world workflows to help speed up or simplify operations and deployments. We'll also look at specific examples of intent-based networking that is currently being implemented, specifically on Big Switch's Big Cloud Fabric and SDN Fabric for next generation data center switching. And Angelique will walk us through some of these workflows in the form of a video demo. So as we have seen, data centers are getting modernized one at a time, or portions of existing brownfield data centers are getting modernized on a pod by pod basis. And the focus of these enterprise data centers and service provider data centers is really to be more and more software centric, more and more software defined, whether it's for compute, whether it's for networking, or for storage. And the key driver for this is new classes of applications. If we have witnessed, if we kind of look at networking for the past 25, 30 years, it's really the applications that have driven changes in networking. And the applications now are, modern day applications are cloud native, and that is demanding a new style of infrastructure, specifically networking. I was talking to one of the end users who's been deploying converged infrastructure, and one of the complaints was that 90% of the problem is the network. And it's because compute has moved forward, modernized, storage is moving forward, it is modernizing with software-defined storage, but the network has stayed behind. And there are very specific reasons for that, and but we need to have the network also be a first-class citizen in this modernization game. So with cloud-native applications, really, if one were to say what is, we say real estate, what is the best place to buy real estate, and it's location, location, location. So for SDDC, what is kind of that key theme? And it's really speed, speed, speed. Our end users want to deploy things faster. They want to operate things faster. They want to troubleshoot things faster. They want to, eliminate things faster and innovate faster. So it's all about speed. One can argue that software-defined data centers could be, redefined as speed-driven data center, which is the aspirations that our customers have. So speed is going to be the focus, and intent is going to help us speed things up very, very fast. But let's look at where we have been for the past 25 years. Very boxy network. Every box needs to be configured. Gazillions of protocols and features and nerd knobs that have to be turned on. They all have to operate in synchronism for the network to operate in a stable, consistent, and scalable manner. The interface that we have is an old 90s interface. In the 90s, it was a great interface. And as we approach 2020, it is a pretty old interface. It needs to change. And the interactions with networking is very cumbersome, very brittle, hard to troubleshoot, breaks very fast. And so this has been the barrier, and no wonder 90% of the problems tend to be networking. So what is, how does intent help? First of all, what is intent? Well, we use intent every day as humans. Let's kind of look at what are the steps we take in order to deploy network infrastructure. We want to design our intent. There's design intent. What does that mean? We want to deploy a 16-rack fabric per rack. We want to have dual TORs. Has to be non-oversubscribed or whatever the performance characteristics you may want to impose. Intent is to instantiate certain types of workloads, maybe VMware workloads or container workloads with Kubernetes and Docker. That's our design intent. We want to design infrastructure and network according to those principles. Then as we deploy this, whether it's day 0 deployment, day 1 deployment, day 2 deployment, we have constant change management on operational practices that need to be addressed, such as I want to add a switch, leaf or spine. It has to be added to the fabric, and the fabric has to be formed with these changes. I want to add a server, add a VM or a container. I want to troubleshoot whether a source VM is able to connect to a destination VM. So this is all the intent that we talk about. We as humans, network operators, manage this. But the step that is the next step, implementation. This is where a lot of the details get defined. The mapping from what needs to be done, our intent, to how it needs to be implemented, all the little detail steps. This is where it slows us down, because it's the human who is thinking, the brain and the mind is focused on intent that is operating at very high speed, but our hands and eyes and ears are doing the implementation, and that's where things slow down. And it has to be done on a box-by-box basis. So with intent-based networking, the idea is to split the functions, let the humans do what they do best, which is really design and deployment, really focus on the intent or what we want to do, and let the machines deal with all of the implementation details, all the menial tasks that machines are best at doing. So here, the brain is doing what it's supposed to do, what it does best, and machines are doing what the machines are supposed to do best. What it means also is that as infrastructure demand increases, in IT environment, we constantly keep adding new workloads, and that means new infrastructure has to be instantiated, while the old infrastructure, the legacy applications continue to be there until they are they're removed and they have long lifetime. So, however, the constraint that we operate under is that the budgets are not growing. And so within a constant budget, constant team, how do we ensure that we can continue to manage and operate, deploy and operate more and more infrastructure without getting stressed out? And by driving intent and letting machines do what they do best, and what humans do what they do best, we can bring that speed and agility that SDDC operators demand, our customers, our end users demand. At the same time, we meet the budget constraints of the team being able to operate more and more infrastructure. Now, is there an analogy to this? And I really like the automobile analogy, and car industry really got this right, and unfortunately the networking industry is struggling to get it right. If we look at the engine, car engine, it is a highly complex piece of machinery. It's got lots of nerd knobs, lots of features, a very complex timing sequence that needs to be set up in order for the engine to operate efficiently. If all of those features and node knobs and timing sequences were to be exposed to the user, you would have a very fancy, complex dashboard that you would have to operate, and no longer can a 16-year-old be able to drive a car. But the car industry didn't design the car that way. They designed it for humans, and so they focused on the human workflows. Humans want to steer the car, brake the car, accelerate, drive, navigate, and this is what's exposed to the user, so that even a 16-year-old who is not drunk can drive the car. And all the complexity is left under the hood, where it belongs. And this baseline is allowing the car industry to take the next important step to autonomous driving, where with machine learning and all kinds of intelligence, we are witnessing cars, self-driving cars. And so for the network, unfortunately, the baseline has been, very feature-based. We have exposed the engine to the user, to the driver, and the drivers don't like it because it slows them down. So we need to take the engine back and push it under the hood. And this is what the focus of Big Switch Network has been. Our baseline, our starting point is intent-based networking. And we'll see the workflows that we want to talk about, the ones that we earlier mentioned, intent-driven. I want to add a VM, switch, server. How do I not do anything to the network? How does the network automatically configure itself? Or that whatever my touch points are very little, 1 or 2 clicks, and one is able to operate the network. And the fundamental clue to achieving this capability is that, if I, instead of 100 switches, which I need to configure, if one were to say all of those 100 switches appear as if it's one logical switch, obviously redundant logical switch, then I need to configure only once instead of 100 times. And this is really the insight that we will use to see how intent-based networking can be a reality today, and one that Big Switch is providing today. And it allows us to really be ready for the upcoming revolution or evolution in networking from intent-based to self-driving or self-operating networks, autonomous networks, where knowledge becomes important through machine learning, through predictive analytics, being very cloud aware, hybrid cloud aware, to be able to have what the car industry is able to achieve today. So with that, then, is there a framework for understanding intent-based networking capabilities? And there have been several initiatives in the industry. One has been used at Open Network Foundation with intent-based node-bound APIs that are being talked about. And the other, more recently, is a framework presented by Gartner, where it actually, talks about what is the difference between intent-based versus, status quo, which is, very box-by-box, human-driven, human middleware, very nice term, as well as the difference between intent-based and automation and orchestration. And this chart really shows that it's not, certainly intent-based includes, automation and orchestration, but additionally, one has to validate the intent, pre-validate it as well as validate it in real time, determine the real-time network state, take dynamic actions based on the network state, and be able to have business-level, intent, business-level input to create workflows and policy configurations. So we'll see how this framework also applies to some of the workflows that we are going to talk about in the rest of the talk today, and also during the video demonstration that Angelique will walk us through. Now, if we look at innovations, Gartner also has a very nice framework for seeing how innovations are being brought by the industry players, and it's nicely mapped into Gartner Magic Quadrant. And if you look at sort of the x-axis, completeness of vision, as you move towards the right, those are the players who are doing innovations. So the visionary quadrant here, it's very interesting to see the companies that are highlighted in the visionary quadrant. Really, here it's all software-defined or open hardware. So you look at Dell EMC, offers open networking hardware, and also multiple third-party network operating system vendors, software vendors to provide that. VMware, a software vendor providing overlay SDN-based networking, network virtualization with NSX, and certainly Big Switch Network, which provides SDN-based networking for the underlay or for the physical leaf-spine network. So really, if we look at the visionary quadrant, it is purely made up of players who are either providing software-defined networking, software-based networking, or open networking hardware. Very, very interesting, and clearly the trend really shows that the wind is blowing in that direction of network transformation. So for Gartner, CLI is basically dead, API is cool. This is fundamental now to new class of networks. Value is really in software. Fabrics are the new normal, and open standards, multi-vendor interoperability becomes a mandatory requirement as we drive towards SDDC, right? So there's fundamental requirements from the end users. And what we've seen with Big Switch is really offering a very cost-effective, commercially deployable, production-grade, scalable, and resilient SDN fabric, which use open networking switches, for example, from Dell, as well as white box switches, to drive down the overall cost to up to 50% less. And this is leveraging, a centralized controller, very simplified GUI, single pane of management, and integration into cloud orchestration platforms to provide highly automated network solutions. And we'll see that these become the ingredients to then provide us the intent-based networking that is ideal for humans to operate. So what we'll do now is really go back to the question of how can we simplify networking, make it intent-driven. If we have box-by-box networking, then our intent needs to be implemented on every device, every switch in a router. And if we have 100 such switches in a fabric, then we have to configure those 100 times. So the clue here, as we kind of earlier looked at, was that if we make those 100 switches or that fabric appear as if it's one redundant logical switch, then we would have to do configurations only once, or operational practices become, operating only one logical entity. And so here is a perspective of this. So if we take a chassis architecture, which has, line cards, backplane, fabric, and supervisors, if we take a pair of these chassis and we disaggregate them, what do we get? We disaggregate these three canonical components. The supervisor is essentially an SDN controller. This is where we would configure, L3 protocols, for example, BGP. Fabric backplane essentially acts as a spine of a fabric, and the line card, which is where the Ethernet ports are, and all the external entities connect to the switch, this becomes leaf switches. And with this, one can build an architecture that makes this entire fabric appear as if it is one logical switch pair, just like the two chassis appear as if it's one logical switch pair. This disaggregated fabric that is made up of leaf spine and an SDN controller can be made to operate as if it's one logical chassis pair. What the beauty of this architecture is that it's a elastic chassis. You can start with a chassis that is 2 slots and keep adding leaf and spine switches and get to 136 slot chassis. So it is scale as you need architecture versus the traditional chassis architecture where once you buy an 18 slot chassis, you're stuck with it, and next time you need a 19 slot, you have to buy another 18 slot chassis. Another important aspect is that the controller function is on an x86 server, so it has tremendous performance, it has tremendous memory capacity, hard disk capacity, and so a variety of innovations can be brought on the controller independent of the fabric. And this allows innovation velocity to really accelerate, which is something that we have seen to be a major challenge in networking. So with that, how do we take advantage of this and then insert this into a cloud-native software-defined data center? And so the real focus is going to be integrating with cloud orchestrators, and that's exactly what we do with Big Cloud Fabric, next generation data center switching fabric, which integrates with VMware SDDC components, including vSphere, NSX, vSAN, Horizon Dashboard, the VMware integrated containers. It also integrates with OpenStack cloud orchestration, specifically from Red Hat and Mirantis, as well as container orchestration systems such as Kubernetes and Red Hat OpenShift, leveraging Docker runtime containers. And of course, the fabric can be operated as a standalone L2, L3 fabric for a variety of other use cases such as big data and other workloads. So now let's leverage this Big Cloud Fabric and its metaphor of one logical switch pair that is very elastic in its operational characteristics and the fact that it integrates with cloud orchestration systems. How does it help us drive intent into implementation? So our intent here is going to be add a switch, leaf or spine, and we'll see that it's a one-click operation. Form a fabric, we'll see that this is really zero touch. One does not have to do anything once a switch is added to the fabric and connected. The fabric automatically configures itself. Our server team keeps adding servers or removing servers. This should be automated, and Big Cloud Fabric, it's really no touch. It's fully automated MLAC configuration. Oftentimes we want to upgrade the fabric because there are security vulnerabilities. We want to consume new features, especially if the innovation velocity of the vendor is going to be high. Then the consumption of those features needs to be high as well in order to benefit from these new innovative features. And so upgrade becomes very, very important. But when we have 30, 40, 50, 100 switches, upgrade can take many, many weekends and nights. But with intent-based networking, we can get the upgrades to be 3 small steps all within 15 minutes, all of the 130 plus switches. Multicast, one click across 100 switch fabric. Network creation for VMs and containers, such as creating L2 segments, automated, right? As VMs are created, containers are created, network automatically creates the network in accordance with these endpoints. And very important, troubleshooting. When a source is unable to connect to a destination, it needs to be validated, and troubleshooting needs to take place. If we need to do this on a box by box by box basis, it can take hours and days. With an intent-based network, such as Big Cloud Fabric solution, one can do this in one click, and we'll see some of these workflows in action. So let's start with the first one, adding a leaf or a spine switch. In Big Cloud Fabric, whether it's a GUI or CLI, here we are showing it through GUI, but it doesn't really matter. It could be GUI or CLI or through APIs. Very simple. All one has to do is define the role of the switch, enter the MAC address, and MAC address is purely there for the purpose of admission control so that rogue switches don't get added to the fabric. But once a switch is admitted, all one has to select is its role and assign it to a particular leaf group, and we are good to go. So very simple way to add a leaf or spine switch. Now, we've added it, and recall some of the characteristics of intent-based networking, that it has to be validated, and also in real time. And so in Big Cloud Fabric, you can quickly see that each leaf switch is fully connected to the spine switch, and this allows one to do that validation that I have a fully connected leaf spine cross fabric. Now, the other is looking at the network state and then taking dynamic actions, such as reporting errors and warnings. So for example, if we have an issue with cross fabric, the validation is not occurring, then that needs to throw an error. And here, for example, it shows that spine to leaf link is missing, and that throws an error. Here's another example where if one has a dual TOR rack and the two TORs are connected, need to be connected. If the link between the two leaf switches is missing, that shows up as a missing link warning or an error. And here the example is shown in the CLI versus GUI. And finally, what if there's cross-rack misconfiguration or misconnection that is also shows up as errors, and showing that link between the leaf groups is not appropriately connected, or reverse link is not detected, and things of that nature. So very easy to validate the intent using real-time network state. What if we add a server? Well, when we add a server, oftentimes we want to connect to two leaf switches in the rack, and so configure the MLAG. In the case of Big Switch, the MLAG is automatically configured. And also, if there is a misconnection, let's say one of the servers is connected to the other rack switch, you get an error that the host is inappropriately connected to the other rack. And additional MLAG validation also is there, links down or other errors to ensure that MLAG is available, because it's important for MLAG to be up for the servers and the VMs and the containers being hosted on that server to be able to communicate with other endpoints in the network. What about consistency validation of the fabric hardware? Hardware has a variety of OSs. OS version has to be the right one, and also its firmware. This open networking hardware uses Open Network Install Environment, or ONI, and also CPLD. So if there are mismatches, the controller immediately shows what the errors are or what the issues are. Let's look at L3 networking. Very important. This is the one that allows us to forward traffic from one subnet to another, or one segment to another, enables VMs and containers to communicate with each other, and appropriate validation of configuration takes place even for L3. So if no subnets are there, or segment is unknown, these are warnings that are shown. Even the fact that if remote router is not connected to a particular VRF or a tenant is easily detected and shown. So these are various capabilities that we saw on the fabric: adding a server, adding a switch, creating a fabric, that are very easy based on these intents. These are done using one click or in an automated fashion. So really no touch is required, or very light touch is required. And they're validated in real time. Now let's look at VMs and containers. And here, the key theme is to be able to integrate with orchestration systems so that the network intent is inherited through cloud orchestrators, whether it's OpenStack orchestration through Red Hat RHOSP, or from VMware SDDC orchestration, such as through vSphere or NSX or vSAN, or container, Red Hat OpenShift or Kubernetes. And these integration points, actually, when the integration takes place, the Big Cloud Fabric appears as if it's one logical switch. So integration is only at single point, which is the controller, and the controller then takes care of programming the rest of the fabric. And so here are the workflows, and some of these we will walk through as Angelique goes through the demo, such as creation of the VMs and how do we automate the network, adding the host, and we talked about automating the network. vMotion takes place, or IP mobility event takes place, and the network dynamically adjusts itself to that mobility event. Validation of security policies, compliance checks, health of the host, variety of this intent-based workflows are automatically handled. They're built in to the product as it is shipping today. And we'll see some of the demos of these environments. And a key aspect of Big Cloud Fabric is its very unique integration, sort of very innovative integration into the entire suite of VMware SDDC solutions, vSphere, NSX, vSAN, including GUI client for even a vCenter. And this allows network admin and VM admin to be able to operate in a very consistent manner, and network team has visibility to the virtualization environment, and the VM team, the vSphere team, has visibility to the network environment. This speeds up troubleshooting workflows very nicely. And finally, cloud native apps. So these apps reside on container form factors, and these workloads can be instantiated using Docker runtime container, Kubernetes Orchestrator, or provided as a vendor-supported solution through Red Hat OpenShift. And Big Switch solution is integrated into Kubernetes and Docker, and also through Red Hat OpenShift. Here are some examples of these cloud orchestrated workflows. So if a server is to be added, an OpenShift node, when it's connected to the fabric, it is automatically detected, and the MLAG is automatically configured to, in this case, rack 3, and the two leaf switches L1 and L2 on rack 3. And it shows that the MLAG is validated and it's up and active. Now, when Kubernetes within OpenShift creates a container or scales containers from 10 containers to 50, or destroys them from 50 to 5, all of that elasticity demands that network must be appropriately, network segments be created and modified. And with Big Cloud Fabric, through integration into Kubernetes and OpenShift, the container segments are automatically created. The container names are made visible to the network admin. So a variety of container context is now available right in the Big Switch Fabric, Big Cloud Fabric controller. So very, very easy for a network admin to now monitor and operate container workloads. What about troubleshooting? If one wants to troubleshoot, or see connectivity check between a source container and a destination container, or between any two endpoints, whether it's a VM or container or bare metal server, one has to go through this multi-hop troubleshooting process to be able to figure out whether or not the path is working. In the case of Big Switch, it's one command, one click. You select source, you select destination, click on test path, and it tells you exactly the path that flow is going to traverse, including the specific links within the lag formation that flow will traverse on. And so it makes it very easy for network administrators to do the troubleshooting. And all of the logs and events are captured so that if one needs to go back and say, hey, I would like to troubleshoot or look at what happened at 2 o'clock in the morning, one can go and see that a whole bunch of containers got instantiated or got removed, and be able to correlate these events very, very quickly. So this rich set of analytics are also built in. So if we kind of summarize, coming back to the framework that we looked at with Big Cloud Fabric, validation, automation is there, multi-vendor operational capabilities are there with variety of orchestrator integrations, as well as support for multiple hardware form factors and hardware vendors, whether it's bright box or white box. validation of intent, real time as well as pre-validation, determining of network state in real time, as well as taking actions. And so, very important to see that it is really concept of combination of SDN, open networking, integration into cloud orchestration allows us to bring this very sophisticated intent-based networking a reality today to build SDDC environments and cloud-native fabrics. Can legacy environments do this? Anything can be done, but the architecture just is not amenable to do this in an elegant fashion because of the box-by-box networking. Of course, traditional providers will continue to put a shiny wrapper around it, but it's all bolted, management environment, bolted API. It's all afterthought in terms of adding policy and some of these modern concepts. When you have an SDN fabric, intent is very natural. It's very naturally aligned to what SDDC demands, what cloud-native applications demand, because it's all single point of control, single point of policy management, single point of API integration, and it's because of the controller-based architecture that drives the entire fabric into a logical entity. And we have seen customer validations and customer aha moments and wow factors as they deploy big cloud fabric in a variety of environments, whether as an NFV cloud fabric at Verizon with Dell Open Networking switches and Red Hat OpenStack cloud orchestration, or at Dubai Municipality with VMware and big cloud fabric, or NSX and big cloud fabric. Even we have automobile manufacturing company who is deploying big cloud fabric with Kubernetes and Docker. And what these customers are realizing is tremendous benefits in terms of operations, speed, and CapEx.
Awesome. Thanks, Prashant. It was a great presentation. So before we move on to the demo, I just wanted to note that, again, feel free to ask questions as we go through. We have a number of questions that have already come in, and I just wanted to see if we could get to one of them before we move on to the demo. This is a question that's come in and one that we get fairly often, and that is related to whether or not our controller is OpenFlow based. So perhaps we can address that before we move on to the demo.
Yeah, absolutely. The Big Switch controller leverages internal communication mechanisms to build a fabric using normal networking principles. And so there is no need for OpenFlow-based forwarding mechanisms as it had been originally defined. SDN can be built with all of the principles that we know and love in networking to ensure that we can get scale and resiliency that any data center deployment demands, but also be able to bring agility, simplification, visibility into that environment that a traditional box-by-box network has been unable to do. So Big Switch leverages its internal mechanisms to build these production-grade fabrics and does not require OpenFlow.
Great. Okay. So again, we'll get to the rest of your questions after our brief demo. So let's go ahead and get started.
One requirement that we can check off right away is multi-vendor capability. We've already mentioned in the presentation our integration with multiple vendors and multiple systems such as VMware, OpenStack, and a variety of container orchestrators like Kubernetes and Mesosphere. So we meet this fairly basic requirement, and we're just going to focus on VMware today for the purpose of time. And because we're focused on VMware, we're going to spend some time looking at both the VMware admin view as well as the network view through BCF and move between them to show how we automate networking for your VMware environment. Again, we'll get through all of these workflows and some additional ones in our next webinar, but we'll cover a couple of them today. The second Gartner requirement we're going to cover is automates network changes. The workflow that we're going to demo today as an example of this is adding a host and auto link detection to that host. So starting in our Big Cloud Fabric GUI, we're looking at the interface group page here. We have two interface groups here already. An interface group for us is similar to a lag or an MLAG. We're constructing the lag based on discovering the server through LLDP or CDP. So LLDP or CDP needs to be enabled on the virtual switch. We're now going to go over to vCenter and add a host and configure the virtual distributed switch. Then we're going to switch back over to Big Cloud Fabric interface to verify that the host is auto-detected by the networking fabric. So we're going to configure a new VDS, and then we're going to add a host and assign a couple of uplinks. Okay. And finally, we want to make sure that we have LLDP enabled on this virtual switch. And now we can return to our BCF GUI and verify that the interface group is now visible in BCF. And yes, we can see that it has now been added, and information on that host is now available to the controller and is visible in the interface. We can see the two leaf switches it's connected to and the host interfaces. The next Gartner requirement we're going to cover is pre-validation of intent. We're going to validate a policy configuration using VM to VM test path. So suppose that you want to ensure connectivity between two VMs. We can run a test in our system to ensure that our expected behavior is met. In this case, the expected behavior is that we have a valid path between two endpoints, which in this scenario will be two VMs. So we're going to navigate to the test path page in the BCF GUI, and we're going to select our two endpoints to perform the test. So we're going to click on the endpoint button, and we get a pop-up here where we can select from our endpoints, or we can do a search. So in this case, we're going to do a search on IP, but I can also search based on other information, including VM name. And I'm going to do the same thing for the endpoint destination. Again, performing a search, finding the desired destination endpoint, and selecting it. Then I'm going to run a simulation. This is going to show us the expected connectivity based on the configuration. So I'm going to simulate the connectivity between the two VMs, and I see here the source and destination. And then I'm going to create a test to validate this configuration. And then we're going to wait as the test is performed. We can see here the status. Okay. And yes, we have validation. So we can see the configuration is working as expected. So finally, we come to the last criteria on our list, which is the ability to ingest business level input that can then be acted on by the system. We've already looked at a set of simplified workflows that can be handled by the BCF networking system, so we're going to approach this notion of business level input in terms of network abstraction or virtualization. Big Cloud Fabric supports this concept of a logically isolated tenant space that we call a vPod. You can think of a vPod as similar to a virtual private cloud. Multiple vPods can be implemented on a single shared physical fabric, essentially the same infrastructure, with logical separation, tenant isolation, and different policy configurations. So you can connect multiple vCenter instances with its hosts connected to BCF, each potentially representing a different application or a different tenant. You can even connect multiple orchestrators, including OpenStack, Kubernetes, Mesosphere, and others, all leveraging the same physical fabric, but with logical isolation. So coming back to the BCF GUI, we're going to take a look at how this would be represented in our system. So we're going to navigate to the integration section of our interface and take a look at the VMware section. So here we're showing multiple vCenter instances, each of which has been assigned a function. So we can see some examples of this where you might allocate resources based on application or tenant.
So with that, we're going to go into our Q&A session. So the question is, I can see one logical switch per data center pod. What is your argument for expanding the logical switch to encompass an entire data center instead of limiting the complexity and blast radius on a per pod basis?
Yeah, typically we've seen customers really focus on availability zone-based designs. So they would like to deploy multiple availability zones within a data center. And so we see Big Cloud Fabric being deployed, along with legacy infrastructure for greenfield pods. So you would have a pod of 500, 600 servers. That's already 10,000 or so VMs, so fairly large pod. But one can start with a 2-rack pod all the way up to 64 racks. And so the idea is to be able to insert in a manner which is comfortable from a availability zone or blast radius perspective.
Great. Another question that we have is the API REST, CLI, both other?
Yeah, that's actually a great question. For intent-based networking solution, one needs to have an API first principle. So API has to be native. It has to be first-class citizen. And Big Switch has essentially adopted this principle. And so in Big Cloud Fabric, the way features are designed is with REST API first, and then any interactions that take place through GUI or CLI, both are clients of REST. What it means is that CLI, GUI, and REST are always consistent. REST APIs are always tested, and they are hardened because of this. And so unlike traditional box-by-box networking where CLI tends to be first and everybody else is second-class citizen, which makes it very, very hard for those infrastructures to be able to bring intent-based networking capabilities and some of these modern concepts of automation and agility, which we have avoided because of a very important architectural choice from the beginning.
Great. We don't have a lot of time, but perhaps a couple more questions. So one of the questions that we have is there any impact to the traffic within the fabric if the controller fails?
So what we offer is a high availability design that our customers deploy. And in a high availability design, you would typically have, multiple spine switches so that any failure in the spine switch is managed. For workloads that require resiliency, dual leaf switches with the server connected in MLAC fashion to the dual leaf switches within the TOR, and dual controllers. So that any single point of failure can be very easily managed. Now, an important question that comes up is that what happens if both my controllers are unavailable? And the traditional academic view of this, from the years past, was that could impact the fabric. But in order for production-grade fabric to be deployed in Fortune 500 data centers, we cannot have such situations to occur. So even when both controllers are unavailable in Big Cloud Fabric, the fabric continues to operate normally. What one cannot do is to change policies, but the existing policies continue to run. Existing endpoints continue to communicate. They can initiate new conversations, and the fabric continues to operate till the controllers come back online.
The question is, any plans to be in VMware Cloud Foundation HCL, so hardware compatibility list, and integrate with SDDC Manager via hardware management service?
Great question. Our philosophy is to integrate into as many popular cloud orchestration platforms as we are able to. And thus far, we have done the ones where our customers have deployed these cloud orchestration platforms. And Cloud Foundation is very much an important one that we are considering.
Okay. And this next question is around L3 protocols. So which L3 protocols are supported?
We support today BGP and variations, both IBGP and eBGP, and more to come.
Okay. We have a question around Cisco's recent announcement. So Cisco announced intent-based network for campus. Can it be compared to the Big Switch approach?
Big Switch is really a data center solution. And so certainly in terms of the deployment and use cases, it is orthogonal. The two are orthogonal. But certainly, it is clearly, we are seeing that the concept of intent-based networking is becoming very, very prevalent with the Cisco announcement, and certainly reinforces the approach that we have taken in the data center with Big Cloud Fabric.
Okay. So another question that we have is regarding Big Switch's support for micro-segmentation among a server in the same segment.
Big Switch really offers a physical leaf-spine fabric managed through a controller, SDN controller. And so typically for providing microsegmentation, we partner with NSX, and NSX enables microsegmentation as a network virtualization or an overlay SDN for vSwitches, and Big Switch remains the SDN solution for the underlay, the leaf-spine fabric.
Great. Okay, so this question is around licensing. So is the software licensed by subscription or perpetual?
Yeah, great question. The software for switches is licensed on a subscription basis, on a per switch basis, and the subscription is typically on an annual basis, which includes software maintenance as well as software updates.
Okay, and what is the visibility of network events, network config state from outside the system? So the system is built with APIs as kind of the first-class citizen. So any system outside or any entity outside the system can leverage the same APIs and extract this information from Big Cloud Fabric for its own usage. Okay. And what is this? Okay, so we already got to that question. How do you identify, diagnose, and report interface errors and drops?
This is really the interaction between the controller and the switches. So the two operate in very synergistically, and essentially the controller manages and controls all of the switching functions. Big Switch itself has its own lightweight switch operating system to which the controller interacts. And that switch operating system is actually based on open source Open Network Linux or ONL environment. So there is a a very close coordination between the OS and the big switch, switchlight OS on the open networking switches and the big switch controller, SDN controller, to be able to extract that information and provide it to the user.
Okay. Is this okay? So this question is around container orchestrator. So which container platforms are supported? Kubernetes, Mesosphere, OpenShift, Docker Swarm?
Yeah, great question. So today we have integrated into OpenShift, which also Kubernetes, and OpenShift leverages Kubernetes. We have demonstrated with Mesosphere, and we leverage Docker runtime container engines as part of the solution that supports the container networking, leveraging the CNI plugin.
Okay. This question is around the controller. So in a multi-site deployment, is a controller cluster required per site?
Yeah, that's a great question. For Big Cloud Fabric, because it is a switching fabric and the controller metaphor or operational characteristics are like a supervisor of a chassis, that it is required to be co-located with each pod deployment within or across data centers. However, we have our other solution, Big Monitoring Fabric, where you can have a pair of controllers manage multi-site environment. So that's certainly possible. But with Big Cloud Fabric, we have thus far required that it be co-located with the pod.
Okay. This question is around scale. So how far or how large, rather, can the fabric scale in terms of the number of physical ports?
Yeah, so Fabric can scale to 128 leaf switches. And so depending on kind of the size of the leaf switches, typically it's either 48 ports, or you could have 32 by 100 leaf that can be split with 4 by 25 gig per port. So that can be a large number of ports. So so the ports really depend on what the oversubscription rate of the fabric is going to be. But one can populate the entire leaf switch of 48 ports, and times 128 becomes the size of the pod. So very large pod. These are large number of servers, multi-thousand servers, and multi-tens of thousands of VMs can be placed on a single pod. Highly resilient, highly scalable, and we actually run what we call chaos monkey torture test to ensure that the fabric, each software release passes the torture test before it is available for production deployment.
Okay, and this question is around scripting and automation. So this person has a question around Ansible. So what type of orchestration and scripting tools are supported? This particular individual uses Ansible, so the question is around that.
Well, we support Ansible. In fact, with Red Hat, we partner with Red Hat on Ansible playbooks. And one can leverage Ansible playbooks to interact with Big Cloud Fabric controllers, northbound APIs, along with other other entities in the data center. One of the interesting things that we have been able to do or provide in order to even do Ansible-based scripting rapidly, and speed is kind of our middle name, so we want to do everything fast. And so our team has focused on how do we make API-based solutions like Ansible also be done very rapidly in minutes. And so any workflow, whether it's CLI or GUI, can be printed or displayed with the API calls that are being invoked underneath. So no one has to really guess or figure out what the API calls are for a given workflow, type them in, incur misconfiguration and fat fingering. Everything is printed on the screen or is available right in the browser screen, and one simply needs to cut and paste or copy and paste into Ansible or Python scripts and be ready to start the automation in minutes.
Great. So another question is, who is the competitor in this intent-based networking space?
Well, I think it's a new space, and a variety of players have started to message from a marketing perspective their ability to do intent-based networking. But really, the question to be asked is, where is the real thing? And today, one can deploy with Cloud Fabric with intent-based networking in production, and see the sort of the wow factors that it provides, which is very refreshing compared to our experiences in managing an operating box-by-box network, even if there is a bolted-on solution to provide some level of intent-based workflows.
Okay, and this question is around NSX. So do you have published reference architecture on how to integrate BCF with NSX?
Absolutely. There is a tech brief on the Big Switch website, and we have a detailed deployment guide that we can share under NDA as part of the POC planning with you. So feel free to contact us or our sales team through the portal, info@bigswitch.com.
Okay, and this question is around intent-based networking. So when you say intent-based networking, does that also mean declarative policy implementation versus imperative?
Intent-based, declarative way is sort of the modern way to express how we can enable these modern workflows, and so we leverage. At the end of the day, it is how, but we leverage declarative principles to implement intent-based workflows. Great.
Okay, so just one more question before we wrap up today. So this question is, what is the story for hybrid network with Big Switch alongside legacy or other technology? So how do you roll it out incrementally?
It's very important in networking. There is no, almost, very rare to do a complete forklift upgrade. For networking, it has to be incrementally deployable. And so the way SDN fabrics, specifically Big Cloud Fabric, is deployed is you have an existing brownfield data center, you have legacy 3-tier architecture, and this is all connected through core routers. One would deploy a pod or multiple pods of Big Cloud Fabric, each pod designed for a specific blast radius, anywhere from 2 racks to 64 racks, as earlier mentioned. And this pod managed through a pair of SDN controllers or Big Cloud Fabric controllers, then connects to the existing core router at layer 3 using BGP, for example. And so this way, the new pod, the Big Cloud Fabric-based pod, is able to communicate with legacy applications, but is deployed as a greenfield pod in a brownfield data center. And one can keep adding these pods so that one can get that scale-out effect. One can retire pods depending on the life cycle of that pod and not impact any other application or infrastructure within the data center. So very easy to insert and remove this pod-based architecture, which Big Cloud Fabric adheres to. And this is what hyperscalers do. They have multiple versions of pods depending on the applications and the use cases, and they get rolled in, and older ones get rolled out, and within the same data center. And same principles and philosophy we have also adhered to with Big Cloud Fabric.
Great, thanks, Prashant. So we're running a little over time, so we're going to wrap up. If we didn't get to your question, we'll go ahead and follow up with you after the broadcast. So it's very easy to get started with our solutions. Again, I mentioned the labs. That's an excellent way to get acquainted with our products and to really use them in a very real world similar environment. So you can go to labs.bigswitch.com to do that and sign up for an account. We also have a number of resources on our website that you can leverage. So we have a number of archived webinars, as well as demo videos, white papers, analyst reports. So please check that out. And we'd also like to invite you to join us for our next webinar, which is coming up. The topic for that is deploying an ideal SDN fabric for VMware SDDC. That's taking place on Wednesday, August 9th at 10 a.m. Pacific time. And following that webinar, about a month from now, we'll also have a VMware related webinar. So stay tuned for that. So with that, we would like to conclude the broadcast today. Thank you again for joining us, and have a great day.